Hello, welcome back to another episode of Math with Haus. Now, we're taking a different approach with this video in that it's not part of any of our playlists, it's just a random video. And it is on prime factorization with Google Sheets. So, I don't know about you, but I get annoyed sometimes whenever I encounter some random number, like how about, let's see here, 658,997. Suppose I have to factor that. Well, that'll take a while. I mean, you have to run through all the prime numbers. You have to take square root of this, run through all the prime numbers till you hit that square root value in order to figure out is that prime or not. And doing that by hand is a lot of work. So then I think to myself, well, I can just go on the internet. Let's see what Google says. Is this a prime number? Yes, it is a prime number. Cool. But however, keep this in mind. Why is 11 not a prime number? The internet's broken. Now, I don't know about you, but I don't like doing this over and over. Checking out whether a number is prime or what its factorizations are. It would be nice if I could just simply plug a number in and have Google tell me, hey, this is a prime number. That is what we're going for right there. That is our mission. Our mission is to make Google do the prime factorizations for us using a spreadsheet. So, first order of business is we need to have a field for input. So here's our, right here we're going to plug in a number. And now our next step is we need to figure out how are we going to approach this. Now, we could use several cells here and make a calculator using just the spreadsheet functions. That would have to take a lot of time, and it would, yeah, it would be a lot more work than I want to do. So instead, what I decided to do is spend some time to learn what JavaScript is all about. And if you click here on Tools, we can use the script editor, and we can make our own little script. So if we do that, then we can see, oh, there's my code from me figuring out how to do this. But what we're going to do is click New and Project. Alright, so New Project. This is what your new project looks like. And we're going to change this. So let's delete that. Let's give this a new name. Let's see here. I'm going to call it Math with Haus. Fun times. Because this is indeed fun times. Alright, now one thing to note is when you do define your function, you probably don't want to pick a super long name because then you have to type it all out. And it's probably even more annoying when you do the capitalizations like what I did. So that's a pro tip there. Oh, we should probably name this. Call it prime factorization example. Factorization example. So we got a name, we got a function name. Now, notice here we got curly bracelet and I said bracelet, I meant bracket. Alright. So all of our code has to go in between these two curly brackets. And there's nothing inside these parentheses here. So what we're going to do is we need to put something in there so that we are taking the value from our spreadsheet and it's being plugged into here. So I'm just going to call this input for lack of a better term. Now our next step is we need to define some variables. Okay, so how we do that in JavaScript is we use var for variables. So we're gonna call, yeah, we'll call it factors. Why not? So all the factors I'm going to put in this variable, and the way I'm defining it with these square brackets here, that means it's going to be an array. Okay, so an array is a data type where you can have many values. So for example, if I had some variable called fish, and I suppose I should use the notation of JavaScript. So inside fish you can have, say, salmon as one entry, halibut as another entry. And we need to have trout. How about bass? Alright, so this would be an array with 4 elements in it. Each of these is saved all inside just one variable that we called fish. What we're doing is saying we're going to make an array, but we are just putting one element inside. So salmon would be one element, halibut would be a second one, and I'm just putting a 0 in. Okay, and then I'm going to do a second array and call it exponents. So the basic idea here is if you have something like, well, if we think about 8, that's equal to 2 cubed, right? So I'm going to store the 2 in the factors, and I'm going to store that 3 in the exponents. Okay, so that's how that's going to work. Now the next thing I'm going to do is I'm just going to call some variable. I'm just going to call it a, and I'm going to make it equal to my input. So all the math operations I'm going to do in the function is going to be done to my variable a. That way this value that was inputted originally, that just stays wherever it is without any messing around done to it. Alright, and then I think I'll continue with my fish theme and just call this variable fish, and we're going to make this a array, and this is going to be a 2-dimensional array. So this variable, or this example here, this is a 1-dimensional array. A 2-dimensional array can be something like, how about donuts? So if we had a variable named donuts, we can imagine something like this, where you have, how about glazed, frosted, and then how about chocolate, vanilla, sprinkles, and chocolate chips. So you see, all of a sudden now, with this 2-dimensional array, you got 3 rows going horizontally across, and then 2 columns going down. So what we've done with fish over here in our code is we've made a 2D array like this. Okay, so we got like 2 columns of, or I think 2 rows of data. I think it's 2 rows of data. That's how that works. So yeah, it's 2 rows of data. Okay, got it. All right. So with our so fish is going to be important later on. We could call it whatever. I decided to call it fish because why not? Fish is delicious. All right. And then I'm going to make another variable. I'm going to call it m. And we will explain m and fish more so later on. Okay. So the first thing we need to do is check if our number is divisible by 2. So when we think about any number, we need to check if it's divisible by 2. 2 is the odd case, in that, pun intended, in that it is the only prime number that is an even number. All the other prime numbers are odd. So to account for that, I worked it out like this. So what we want to do is use what's called an if statement. So you have if, then we need to state some condition. So I'm going to use a and then a percentage sign question mark. So what this says is we have a percentage sign 2. What this says, this is the modulus operator. So this says a modulo 2. What we're checking for is if this is equal to 0. So in other words, if I have my number, in this case it's 8, if I divide it by 2, we all know we get 4. But what we don't think about is the fact that this has a remainder of 0, right? if I took 8 and divided by 3, well, 8 divided by 3, 3 goes into it 2 times because 3 times 2 is 6, but then I have a remainder equal to 2, right? So 3 does not divide 8, but 2 does divide by 8, does divide 8. So whenever a number divides 8, or whenever you have a number that is able to be divided by 2, like 8 here is divisible by 2, the remainder is going to be 0. So we're checking if a number is divisible by 2, and if it is, then we need to account for that and put that in our factors and exponents. So what we're going to do, so don't forget we need to have these curly brackets. Everything inside these curly brackets here, that is inside our if statement. So if it is true, if this condition is true, then we need to tell our function that we need to plug in a value into our factors. Now, it needs to go in the first entry in factors. The fact that since 2 is divisible, it is a factor, needs to be plugged in to our variable, our variable right there. So what we're going to do is use m to keep track of which element is in our array. Okay, so when we set m to 0, that means the very first value in our array, if our number that was input is divisible by 2, then we're going to put 2 into our factors. Now, if you have something like 8, right? 8, if we divide by 2, that's equal to 4. Well, 4 is divisible by 2, right? And that's equal to 2. And then 2 is divisible by 2, and that's equal to 1. In other words, we know that 8 is equal to 2 cubed. So we need to figure out how many times does 2 go into our input value. And in this case, we know that is 8. So what we're going to do is use what's called a while loop. So what we're going to do is say, while a is divisible by 2, so here's our condition. While a is divisible by 2, we're going to do 2 things. One, we are going to say we're going to reassign our a value. So what this says here is a is now going to be whatever a previously was divided by 2. So the first time through this while loop, our 8, well, we're going to divide 2 out and we get 4. Then the while loop's going to look and say, oh, we got a new a value, and this value is 4. Oh, since it is divisible by 2, we're going to divide another 2 out, and we're going to keep doing that over and over. And while it does that over and over, we can keep track of this using our exponents here. So our exponent, remember m is still 0 at this point, and since it's 0, how many times this loop goes through this process of dividing out a 2, we're going to count those up. And we're going to do it in this manner. Exponents m plus 1. Alright, so by default we said that the very first value in this variable exponents was 0. Now, if it is true that our number is divisible by 2, all of a sudden our exponent, we're going to take the first time through the loop, it's going to be 0, and we're adding 1 to it, and that's the new value. In our case, with our input of 8, it's going to do this 3 times, and each time we go through it, it's going to be adding 1, and so when we're done, it's going to be 8. Now, since we in fact did find a factor, this m here is keeping track of our entries in our arrays here, factors and exponents. So what we're going to do is do m plus plus, then semicolon. So the plus plus signifies that we are adding 1 to m. So now instead of m being 0, now m is going to be 1. So when we do our next operation down below, we'll be good to go. Alright, so one thing to also note, if you haven't noticed by now, is at the end of every line of code here, except for when we just have these curly brackets, we are ending it with a semicolon. Be sure to do that, otherwise your computer will be sad at you. We don't want sad computers. Alright, make a computer happy and don't forget those semicolons. Now, it is good practice when you make code that you only do a little bit at a time and you test it and make sure it works. So to test whether this works, what we're going to do is do what's called, we need to return this value, right? So right now we're just going to check if it's divisible by 2, and then we need to return that value back to our spreadsheet over here. In fact, we need to return the factors and the exponents. And how I'm going to do that is this. So I'm going to type return, and then since we need to return 2 variables, I am going to use a square bracket, so factors comma exponents, and then don't forget semicolon. Now I'm going to do Control S to save this. Oh, we got a problem. Ooh, I forgot a equal sign right here. Cool. Thank you, Google. See, I make computers sad when you forget equal signs. I'm going to hit save. Alright, Google likes this. So now we're good to try this. So now you can see the downside of calling this math with Haus fun times. Alright, so that's my entire function. Notice that is this right here. Math of Haus fun times. Word or letter for letter. And I'm going to plug in A2. And I'm going to hit enter. It's doing its thing and voila. Ooh, yeah. So notice we got our first term here, that is our factor 2, and we have our exponent. Hooray, it works. Let's see here. 1024. Ooh, there we go. 2 to the 10th. That is 1024. It's working. Alright. That's exciting. So with this, we need to figure out now what happens if we have, say, 15. This says 0, 0. Why does it say that? Well, it's simple. We didn't tell the function to do anything in the case when it's not so that our numbers are divisible by 2. Alright, so now we need to figure out all the other factors. Now this is going to be a little bit more complicated, and I'm going to be kind of lazy about it. So here's how we're going to do this. First, I'm going to start with a while loop. Okay, so what we're going to do is say while a is not equal to 1. Curly bracket, curly bracket. So what happens is, as we work through a number that's inputted in, like if I had 1024 earlier, I divided it by 2 10 times, right? So if I divided it out 10 times, I don't need to go through all this work of checking, see if 1024 is divisible by 3 or 20 or or not 20, but like 5 and 11 and whatever else prime numbers there are. So what I'm going to do is say, well, a is not equal to 1, then we're going to do all our fun. In this case, if it's just simply like a power of 2, like 2 to the 200, it's going to bypass all of this work right here and just return. Okay? So that's the idea of this while loop. And also, all this work that we're about to put inside this while loop, we're going to divide out factors as well. Okay? So if you had like 3 cubed times 7 to the 5th, right? We need to divide out all those 3's and 7's until we just get a 1 remaining. As we saw right here, if we divided out a 2, we got 4. If we divide out another 2, we got 2. Divide another 2 out, we got a 1. In the end, our a value is going to be reduced to a 1 when we're done. and that's when this while loop is going to complete. Alright, now we're going to use another type loop called a for loop. And when you use a for loop, what happens is you define a variable, and that variable is only going to be an operation inside the loop. In this case, our variable is I, and its initial value is going to be 3. And what we're going to do is say that I has to be less than or equal to the input. Alright, if I is less than or equal to the input, and then we're going to take our I and add 2. So notice automatically I'm doing things a little differently here. First, I am making this condition here. So I is going to go through every single odd number, starting from 3, all the way to whatever number was inputted. So in this case, if it was our case here, it was 15, right? So that means 3, 5, 7, 9, 11, 13, 15 are all going to be checked. And I'm doing this for 2 reasons. One, if you do the square root business and all that, for some reason I don't think Google liked that. It's probably something I was doing wrong on my end. But by doing it this way, it is actually, I found it be convenient for later on. On the one hand, however, I do have to mention it is probably bad programming practice to have it go through all of those odd numbers, simply because you're pretty much wasting a lot of computer memory. But it's Google, they have lots of memory, so who cares if we waste a few milliseconds of it. Alright, so we have this loop going on. It's going to do every single odd number. We're going to get duplicates. So like if you think about 9, right? We don't really need to check if it's divisible by 9, because the case with the 3's is already going to do that, right? It will divide out all the 3's. But who cares? We're going to keep this simple. So now what we want to do is this: if our a value is divisible by whatever I is, and this, when you first go through, it's going to be 0 or 3, right? So if a is divisible by 3, for example, then we need to tell our 2 variables that, hey, it's true. So here's how we're going to do this. So factors. Now keep in mind, if we had something like 2 times 3, so 6, right? We've added 1 to m. But if we had something like 15, then m is still 0. Either way, though, whatever m is, we are plugging in our I. So in this case, if it was, in our case, it's 15. So that means 3 would be plugged into our factors. And then we need to tell our exponent variables, hey, you need to be equal to 0. So in this case here, if you had a number like 6, m is already equal to 1, right? Because we added 1 here. That means in this case here, the way this is defined, it's actually adding a second element. So if you had or second entry, so for the number 6, we have m is equal to 1, and inside factors, you already have a 2, and inside exponents, you already have a 1, right? Because it's 2 to the first times 3 to the first, that gives you 6. So what this here is saying is, now at this step here, you have factors that is at 2 comma 3, and exponents is now going to be 1 comma 0. We're putting a 0 here for now because we're going to do another while loop, kind of like what we did here, and we're just going to pretty much, the code's going to be very similar. So let's give us a little space, a while, and here's our relevant code. So instead of a modulus 2, it's going to be whatever I is. And we need to see whether that's equal to 0. So this says, first time we go through, it will say, is a divisible by 3? Next time it goes through, is a divisible by 5, etc., etc. Notice before I start typing everything in my loops and if statements, whatnot, I am doing the double curly brackets first so I don't forget them later on. So this is going to look familiar too. We're going to say a is going to equal a divided by I. We're going to divide out whatever that factor is. And we are going to add in our entry m of our exponents inside that whatever that value is in m plus 1 in parentheses. So there we go. Now the next thing we need to do is, just like here we added 1 to our m value to keep track of our arrays, so we're going to add 1 to m right here. Alright, now at this step we are good to check. So let's hit save. Let's plug in, how about 20? Processing. Error. Let's find out. Do we get error or do we get something? I think this is a sign we did something wrong. So what I was suspecting that might be the thing wrong is right here. I did an I plus 2. I was questioning that. So I'm going to make that I plus plus, and then I'm going to do I plus plus down here. So what this says is we're just adding 1, and then since we're only adding 1, we really actually need to add 2. I'm going to add another 1 here. So every time we go, after we go through the loop, we're adding 1. So it's like our for loop is definitely adding to 2. Okay. So now I'm going to save. So notice I have my I plus plus outside my if statement. It's not inside it, it's outside of it. Okay. Let's check. Hey, now it works. Hooray. So notice we have 2. That's 2 to the second times 5 to the first. So that, no, it's 4 times 5. Yep, it's working. Alright, let's plug in 15 now. 15, 3 to the first times 5 to the first. Alright, how about 125? 5 cubed. Alright, how about 250? Alright, cool. Now, how about 29? 29, and 1. Alright. Now, what we're going to do is make another variable, and let's see here. What variable? It doesn't really matter what you call it. So I'm going to call this taco because tacos are delicious. So at this point, when we have this situation here, I already knew it was a prime number. I probably should not have it input that's equal to 29 first. Instead, we should just have it say this is a prime number. So let's type out this. This is a prime number. Period. Alright, so we have a variable, taco, and it's equal to this string of characters here called this is a prime number. So we're going to modify this. So we do this, so we're going to call it, how about we call this a prime check. Prime check. So if, now because if we think about prime number here, prime number is going to go through everything, right? And once it goes through all these loops and whatnot, it factors here is going to only have one entry in it, right? And it's going to be equal to the input. So I'm going to say this is going to equal input. So if this is the case where our factors is equal to the input, then we're going to just return taco. Okay. and that's going to display our thing. And if it's not true, then we're going to say display something else instead, and this something else is our original thing. Okay, now let's save this, and let's see what it did. Error. Uh-oh. Input? We typed something wrong? Did I really? That needs to be input, not input. That's hilarious. There we go. This is a prime number. Hooray. Now let's go back. Our original value. So, 658,997. Enter. Hooray, this is a prime number. This is more convenient. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see what the factors of that is. Oh, what do you know? It's a prime number. That's interesting. 1, 2, 3, 4, 5, 6. Now we know it's broken. We broke something. I wonder what we did to break it. What did we do to break it? Tell you what, let's do this. Control save. Aha, fixed it. Alright. So, I forget, but with JavaScript, there's actually 3 settings. There's an equal sign, there's a double equal sign, and there's a triple equal sign. I kind of, let's see here. So when we use this one, that's pretty much saying, make sure this value, whatever it is, matches that one. Okay. I forget what the distinction between this one and this one is. So there we go. Now let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. See if that really is a prime number. Ooh, it's not. It wasn't. So there we go. There's the factorization. Now, myself, I don't really like this display format. So you have 2 options. One, we can do some shenanigans inside here to change the way the output is displayed. Or we can be lazy and just use already built-in function. So I'm going to use what's called the transpose function. So transpose, what it is a operation from matrices, and what it does is it switches to values in the rows and columns. So notice we now have 3. Our 3 is now here, or it stayed, but our 2 moved from here to here. So our row became our row 1, here became our column 1, and our row 2 became our column 2. That's very handy. So now when I look at this, I know 3 to the second times 3,607 to the first times 3,803. So here's our factors, here's our exponents. Alright, so there we are. There is our nice prime factorization. There's all the code right there. Feel free, have fun with that. This is free for all of you to use. Otherwise that would be awkward if I make a video and say, no, you can't use that. No, I want you to use it, because that can be a pain to factor by hand. And I am going to be sure and use this in my class now. Alright, if you've enjoyed this video, please consider subscribing and supporting us on Patreon. Every once in a while when I get the random inspiration to do something like this, I will try my best and figure out how to do it in Google Sheets, so that we can all reap the rewards of never ever having to figure how to factor some large number by hand and wondering whether these are actually prime numbers or not, or trusting ourselves to the internet and asking it whether it is a prime number. Like what we saw, was 11 prime number? Shame on you, internet. Alright, see you next time.